Hello guys, welcome back to my YouTube channel, and it's been a very long since I have come with another video. In today's session, we'll be discussing about real-time system development methodology. Before getting into the topic, let me introduce myself. My name is Chandana and I'm from Sri Venkateshwara College of Engineering, pursuing my final year in electronics and communication domain. And here we will be discussing about real-time system development methodology, and the code for the particular topic is 18EC731. Without any further delay, let's get started with the session which is to be discussed today. Uh, okay, let's see what are the methodologies which is used for the development of real-time system. First of all, real-time system development methodology are approaches for or frameworks that guide the process of designing and implementing real-time system. So the methodology are the approaches or the framework for designing and implementing real-time system, which must respond to certain stimuli within a specified time time that is response should be given for the specified time for particular stimuli. Here are the explanation of two real-time system development methodology. Let us see what are the two types of methodology that is used to develop real-time system. The first methodology is waterfall model with modifications for real-time system. So the first methodology is waterfall model. So the overall view of the waterfall model is like the waterfall model is a traditional software development methodology. It is a traditional software development methodology that progresses through distinct phases such as requirement. It is composed of different phases, which is such as requirements, design, implementation, testing, and maintenance. Real-time system, however, often require modification to meet their specific needs. So for specific needs, the real-time system will be modified based on the requirements. So the modification for the real-time system are of four types, that is requirement analysis, design, implementation, and testing. In real-time systems, a key focus is on defining and analyzing the timing requirement, which plays a very important role. This includes specifying the maximum allowable response time for critical task and determining the overall system timing constraint. And for design is the design phase incorporates scheduling and resource allocation consideration. The real-time scheduling algorithm are applied to ensure that the task meet their deadline. It is help to ensure that task the task is completed before the deadline. The hardware choices such as the selection of processor and communication channel are critical to meeting timing constraints. Implementation, the next modification is implementation, that is during implementation developers need to pay special attention to timing issues often involve low level programming to control the precise timing of operation. So the developer will pay more concentration on the timing issues, and they often precise the timing of operation to control the low level programming. The consumption of the time will be controlled. Testing, the real time system required through thorough in testing to validate that they meet their specified time and requirement may involve both functional testing and performance testing under various conditions. In testing, it may involve functional testing, and it may also involve performance testing. This will be the overall view of the water flow model. As you can see the model, you will get to know why it is known as waterfall model, because from low level to high level it keeps decreasing. So on the top we can see the requirement gathering and analysis, then it is system design, then the implementation. After implementing, we'll be testing the functionality of the real-time system, then deployment of the system, then everything is all then all the steps is completed, then only we'll go for the maintenance once the system is developed. That is requirement gathering and analysis, system design, implementation, testing, deployment of the system, and then it is maintenance. Let us see the second methodology for developing the real-time system, that is V model for a real-time system. Okay, let us see what is the V model overall view. The overall view of the V model is that the V model is an extension of the traditional waterfall model. So here you can see V model is an extension of the waterfall model, emphasizing the relationship between each development stage. Here it consists of a relationship between each development stage, like from the analysis to the requirement, to the testing to deployment. The relationship between them is also developed in V model, and its corresponding testing phase. In the context of real-time system, V model is adapted to incorporate real-time consideration. It is adapted to incorporate with the real-time consideration. It is let us see what are the four methodology, like the modification that is done in V model for real-time system. The four uh, categories are verification and validation in parallel, early integration testing, timing analysis, incremental development. Let us see what is verification and validation in parallel. V model for real-time system places a strong emphasis on concurrent verification and validation activity. That is, it plays strong role on verification valid and validation of the activities that is taken place parallelly. It happens parallelly. So that is why it is called verification and validation in parallel. So here the time consuming is less because verification and validation is going on parallelly. This means that as each development stage progress, the corresponding testing activities are carried out uh, parallelly. Once it is developed parallelly, the testing of the developed stage is being carried out. Next is early integration testing. Integration testing, particularly in the context of real-time system, is conducted early in the development process. It is developed this is conducted in the early process of development. This ensures that the interaction between different system components, especially those related to timing, synchronization, are thoroughly tested. Next is timing analysis. The V model for real-time system incorporates detailed timing analysis throughout the development of a life cycle. This includes analysis, work case, execution time, response time, and overall system timing behavior at each stage of development. Timing analysis consists of a V model for real time which incorporates in detailed time analysis for the throughout the development of the cycle. Next is incremental development. The V model for real-time system often encourages an increased development approach, allowing for the early identification and resolve of timing issues that the system involves. So incremental development means early identifying the timing issues which is occurring in the real-time system, and resolving the timing issues that evolves in the system is considered as increment development. So these are the four modifications which is brought in V model for real-time system. And this is the outer structure or the general structure of V model. You can see why it is called V model, because it empathizes the shape of V. And here it is requirement models, system requirement models, architectural models, design component design models, unit design models. And here you can see it is units. For component design it is components, architecture is subsystem, system requirement is integrated system, and requirement model is operation system. Thank you for watching today's video. Please make sure you like, share, comment, and subscribe. Till then, keep watching this video, and I'll be back with another video.